Hello everyone, this is Sally. Welcome to another video. In this video, I'm going to be talking about how you can unit test async function. Testing async function might be a bit difficult than you think. It's because there is timer in it, so you don't know when it's gonna be fired, right? So there is events, there are timers, there is delays, there is async await stuff over there. But in today's video, I'm going to be showing you a few. There's actually two. There's two additional tools or libraries or I don't know object in C# we can use, and it's gonna be helping us a lot. It's gonna be it's gonna be reducing the waste time. Actually, I'll come up with a scenario, and we will be just creating some queues, and we will be testing if our function or queue has completely finished properly. In the example over here, I'm just going to show you what job queue is. It is basic class. It has enqueue function and it accepts action parameters, and it just runs it. This is basically an async function, right? It starts a new task, and within this new task, it is calling my function right away. I'm saying right away, but what does right away mean in computer science? There's nothing right away, so everything has to be in order. And the bad thing, so in the scenario, is that we don't know when it's going to happen. In my tests, let's say this is a unit test. In my test, I want to enqueue something, and this is going to be the action I want to enqueue. So let's say I have a Boolean function job ran, right? So and the default value is false for that one. And as soon as I do the action, I want to set it to true. And in the assert, maybe I want it to be, and should be true. So this is perfect case. It's because now I know what I queued. I queued just enqueued that one. This is an action actually. I queued that action. When this action is fired by the task run function, it is going to set this property to be true. And accordingly, I will be just testing it if it is true or not. It should be true, it's because I said it. So let me quickly run that one and see what happens. So I set this one and it failed. And it's because, let me show it to you in Test Explorer. And it's because it says, you said it should be true, but it was false. Over here it says, but was false. But how come? So I know I set this function, and the second I hit that line, it has created this task, and this task is going to call this one. But what happens here is that this is async function. So this returns you a task. So let me hold the mouse. This returns you a task that can be waited, maybe should be waited. In our case, it must be waited, but I don't want to do that. So it's because I am now running my task in somewhere else, and this is a void function. I cannot wait any void function. It should be available, so it needs to have a get awaiter in that one. And this is the whole logic of queuing something, right? So I'll just send something to you, and whenever you're available in your first convenient, you're going to run that application, fire the call to that to action. So I can set this one, and the problem starts here. So as this queues that one, if you remember, I have a video that I was sharing that I found the bug in Stephen Taub's video demo, I could say, not a video. I was basically explaining, he was basically explaining what happens behind the scene when you call task run. It basically queues up anything into a thread pool. Whenever we have a new thread, available thread, it's going to take it, but it doesn't have to be right away. There are milliseconds, maybe nanoseconds actually, difference. So you might say, okay, if I wait here, for example, you might say, if I wait and let's say task delay, let's say 100 milliseconds. If you say, if I wait here 100 milliseconds while I'm waiting here, and then the other task is going to call that action, this will be true, and this will be true, and it is not going to fail. And this is correct. So this is gonna fix, and this is gonna fix the unit test. But I'm asking you, how long do you need to wait? We write our function, we write our unit tests and they have to be fast. They need to complete fast. It's because there will be many other unit tests. I'm not going to be able to find wait 100 milliseconds in all unit tests. Imagine there are 10 of those, it's going to make 1 second. Imagine there is 100 of those, there's thousands of unit tests doing the similar stuff. So I don't want to waste my time. So I don't know if I need to wait 100 milliseconds or maybe 200 milliseconds or maybe even 50 was okay. So let me test if 50 was okay. Apparently it was. Let's say 5 maybe, 5 milliseconds. Let's run that, probably enough. Maybe 1 millisecond is enough. So for example, 1 millisecond was enough even, but it might not be. So imagine there's a bunch of tests and it is runtime delay. So you don't know how long it's gonna take that action to be called by any other thread pool. Maybe while you're running your unit test, there is a bunch of other threads that using the thread pool and you don't have any available thread. So you would basically have to just wait for that action to be called. In this case, for example, if you don't want to waste your time by just trying to guess how long you're gonna need to wait, there are some useful tools. For example, manual reset event, MRE, let's say. Manual reset event, what does it do? When you call its wait function, for example, here, I'll call wait function, it waits. And not only it waits, it also, let me get rid of that. It also blocks the current thread that it is being running on. So whatever thread is calling this unit test is going to be locked. It's going to be locked as I wait. For how long? For example, you can say, I want UB until I cancel any cancellation token. It's because it accepts also cancellation token. But also it says, okay, give me, let's say, 1 second. I will wait for 1 second. But also, again, the same problem. Instead of awaiting task delay, I'm now waiting. But also, it says if you call my set function, I will not wait anymore. So I will break this one so you can keep continue. Do you see what I did here? So I said, so I queued any action. I don't know when it's going to be running. Whenever we have a thread pool, we have a thread, available thread in thread pool, it's going to call that function action. I don't know when. And I'm assuming in 1 second, it's going to be set. It's going to be called. This is the maximum amount actually. If not, it's going to fail. And it also returns a Boolean. So we might assume result or wait result. So we can check if it is called, I mean, if it is set or not, or if it is maybe failed, it's because it just overs 1 second. But what I do here, I queued up any action. I don't know when it's going to be called. I don't know. But I am waiting for it to be called. It's because when it is called, I'm going to break my wait. So manual reset event Slim, this is the Slim version, and there's a non-Slim version, the thick version, big version. I don't know what version, but non-Slim. So you can basically use this one too. In Slim version, let's say, now we are setting it to timer, not timer, timeout basically. If no one sets this manual reset event Slim, it's gonna break it and this is gonna be false. So in our case, not only job ran should be true here, but also this should be true, right? Because it needs to be set, and this is the maximum time I am waiting. So let's say I was waiting here for 200 milliseconds or 100 milliseconds, and I know how long this is gonna take. It's because we've just tried it. But let me put the test explorer here and see how long it's gonna take. So I'm now running my job. So it was 1 millisecond. So let me get rid these off and await task delay. So 100 milliseconds, let's say, and not that one, 2. And let's run this one. I know it's going to take at least 100 milliseconds. And plus, it's because it is now doing the runtime, blah, blah. So if I run this one, at least 100 milliseconds, it's because I had to guess. Let's say 50, and it's going to be at least 50 milliseconds. But what I did here was super smart. It's because now I'm not guessing how long should I wait. I'm basically telling it whenever you're called, just let me know. It is basically throwing an event which that was waiting, so it's blocking the thread, and then it is letting us know, okay, I need to break. Maybe imagine there is a for loop over there, and it is breaking for loop when we call set one. So ManualResetEventSlim is basically doing this one. But also, imagine more complex scenarios where you are now doing some parallel jobs. Imagine. When you're doing parallel jobs, that means this needs to be called maybe you're queuing up too many elements at the same time. Maybe this needs to be called many times and you want to learn how many times it's being called. Maybe you have 10 jobs and you just send it to any background job and the background jobs start parallel for loop, maybe parallel for each loop or anything else. And you just need to know everything is called. Maybe you can just add a counter over here and say, okay, if that counter is 10, for example, if you have 10 tasks, you can compare it with the number of tasks you have. And you might just say, okay, I can do that. Or there's another cool library, or I don't know, something we can call a library we have in .NET Framework, and it is called Countdownevent. Imagine we have a countdown event here, and actually, do I use this one? Yeah. So we have parallel job runner. Let me get into this one. So what does it do? It does actually, I'm now giving it a job service. It is just calling job services service. This might be something else. You don't have to have a service over here, but I'm also saying create this many tasks at the same time and this many delay there will be in that job service. And when every job is completed, when the completion, let's say the for each loop, reaches that job count over here, and it's gonna say, okay, all job completed. You may assume this is task when all, right? So when you say task when all, it's gonna let you know when the all tasks are finished, right? When they are completed. You may assume it is doing the same thing. But here, what I'm doing here is basically this similar thing. So countdown event. So it's the name as the name suggests, countdown event. So when any event happens, it counts it down. So in here, basically, I'm saying your initial count, actually the parameter's name is initial count. Your initial count is 1. Whenever someone sends a signal to you, which is the term in that case, so whenever someone sends a signal to you, you just reduce you. So you just count down to whatever you have. If the initial count was 5 and you send one signal only, it's going to be the 4. The current count will be the 4. It's because it just counts down by 1. Every signal makes it count down by 1. In that case, actually, I'm now basically sending, I'm delaying over here. So my mock service takes that 100 milliseconds, for example, that nanosecond, and I'm sending it to this one. So it is going to be calling the services. What was the function name? I don't remember. Delay job async function. It doesn't do anything, and I'm basically telling what to do. So it's gonna wait 100 milliseconds, for example, and it's gonna take time, right? So in most of the unit tests, you wouldn't have to wait over here. It's because now this is the reason that you are mocking your services. You don't want it to be actually doing something. But for this scenario, for this purpose, it may be useful. And the parallel job runner, it's basically be running behind the scene. So I'm just going to be calling run job async. It does the same, actually. It creates many tasks. And over here, it basically waits for all. And when everything is completed, it is basically calling that all job completed event. So what I'm doing here is that within this event, whenever it is called, you can basically do the same for everything. But I'm assuming it's going to be called only once. It's because it is going to wait for all the event to be completed. And it's going to be called once only. And I'm now counting it to down. And when everything is done, basically, as you see, there's wait here too. So I'm waiting for countdown to be set either called its signal function this many times, so it can reach 0, or 1 millisecond, 1 second, sorry. Again, this is the timeout. If it is not signaled or counted down this many times, it's gonna just break the loop and it's gonna let me know with this result. So in that result, not only that should be true, but also its current count should be 0. It's because it started with 1 and this called it once and then it reached to 0. And event fired, I have the event fire here. It should be 1. It's because all job completed calls only once. So let me run this function, this test, and see the result. As you can see, both are completed. Let me run both at the same time. This takes 150 milliseconds, and it's because now we started 3 of those, and at least it needs to wait 100 milliseconds in that. So this is taking this long. And instead of waiting 3 times, as it is called parallel, so 3 tasks started at the same time doing the same thing, and it just waited for all to be completed. And when it is completed, it sends this signal. I know this is called is because I'm now asserting it by just checking current count, not only current count, but also the result. So result should be true. What I suggest you is that think more about this countdown event and manual reset event sent, where those could be used. Maybe in your scenarios, it might be useful, it might not be useful, but what does manual reset event slim do is basically you wait until it is set. So it is perfect condition, a perfect application of having async or running the async functions in a sync environment and function, you can say. It's because this is going to be queued up and you don't know when it's going to happen. So you might basically say, okay, wait until this is set and you can put it over here. You can see many examples of in .NET framework as well. That's so Microsoft itself is using ManualResetEventSlim, and it's probably for them first and then for us later. So they're gonna be using this one more than us, obviously. And it might be the same for Countdownevent, but they're there for a reason. So there might be most of scenarios that these are available for you, and this is useful for you. And there might be any other scenarios. Those are just useless for you. Let me know in the comment section below if you have ever heard about Countdownevent, especially ManualResetEventSlim is more famous than Countdownevent, but you might be just using it already. I don't know. Let me know in the comment section below. And there will be actually another video. I'm not sure when, but I am planning to test some timer functions, so maybe retry functions, how you can try retry functions, how you can unit test retry functions, how you can test timer-based or time-based functions. It is a bit difficult as well. Not difficult, but it is unusual to unit test those. If you want to learn about this one, please hit the subscription button, like button as well. And if you have any other question, let me know in the comment section below. Until the next video, happy coding.